Alright, so we're going to continue practicing solving other types of equations because this is something you're struggling with. Probably. Okay, so first solve x to the negative second minus 4x to the negative first minus 21 equals 0. I want you to try this on your own. There are two basic strategies you could do to approach this problem. Both of them are correct. Do what you can. Pause the video, do your best, unpause when you're ready to check your work or when you're confused. Okay, so no matter what you do, you should end up with x equals 1/7 and x equals negative 1/3. We do have to check for extraneous solutions in this problem because the original equation is actually a rational equation, but both of these work. So, what are the two main strategies? Well, one is you can do a substitution. So that's what I'm showing you here. So I said x to the negative first is y, so therefore x to the negative second would be y squared. So then I rewrote the equation. Y squared minus 4y minus 21 equals 0. This is very easy to factor. It factors into y minus 7 times y plus 3. Now, when I set each factor equal to 0, I substituted back in for y. So remember, y was x to the negative first. So therefore, x to the negative first minus 7 equals 0, and x to the negative first plus 3 equals 0. So now I can rewrite x to the negative first is actually 1 over x. Remember, that's what negative exponents do, is that we can rewrite them as positive by putting 1 over the value being raised to the exponent. I also added 7 to the other side at this point, so 1 over x equals 7, 1 over x equals negative 3. Now multiply both sides by x, because that's the least common denominator of this little rational equation, so I get 1 equals 7x, 1 equals negative 3x, divide by negative 3, divide by 7, x equals 1/7, x equals negative 1/3. If I plug those back in here, I do not get a 0 in for the x, therefore it's not extraneous. What's the other strategy? The other strategy is to actually turn it into a rational equation right away. So x to the negative second is 1 over x squared. Negative 4x to the negative first is negative 4 over x, and then minus 21. So now this is a rational equation. The least common denominator is x squared, so I multiplied every term by x squared, and it became 1 minus 4x minus 21x squared equals 0. This is a quadratic equation that also factors. It may not be quite as easy to see how, but it's going to factor into 1 minus 7x times 1 plus 3x equals 0, and then from there I could set each factor equal to 0. I did not do that because I already know that I'm going to get x equals 1/7 and x equals negative 1/3. Either way works. The big part is you have to recognize, though, what is x to the negative second and what is x to the negative first. That's actually 1 over x and 1 over x squared. Next one. Solve. I want you to do this on your own. Hint, factor by grouping. Pause the video. Unpause when you're ready to check your work. Another hint, you should get 4 answers. Keep in mind. Okay, so here we should get x equals negative 1, x equals 1, and x equals 1 plus or minus I root 3 all over 2. How do we get that? Well, I group the first two, I group the second two. I can take out an x cubed from the first two, I can take out a positive 1 from the second two. I have x minus 1, therefore this is working. So I am left with x cubed plus 1 times x minus 1. X cubed plus 1 is the sum of cubes. So you have to use your sum of cubes pattern. So this, x cubed plus 1, factors into x plus 1 times x squared minus x plus 1. X minus 1 just stays x minus 1. Now this is completely factored, so I can set each factor equal to 0. Set x plus 1 equal to 0, I get x equals negative 1. Set x minus 1 equal to 0, I get x equals 1. Set x squared minus x plus 1 equal to 0. I know from the difference of cubes and the sum of cubes this will never factor, and it will always give me imaginary solutions, but those are still solutions. So I used the quadratic formula in this case. Opposite of b plus or minus b squared, square root of b squared minus 4 times a times c over 2 times a. Simplify, and I get 1 plus or minus I root 3 all over 2. Next one. Try this on your own. This is very similar to a problem we did in the last night's video. So see if you remember that or look back in your notes. Okay, so here we should end up with x equals negative 125 over 8 and x equals 1. We do not have to check for extraneous solutions in this case. Why? Well, let's see, what did we do to solve this problem? So what I did first was I brought everything over to one side, and I rewrote it as 2x to the 2/3 plus 3x to the 1/3 minus 5 equals 0. Now, I recognize that this is of quadratic form. So you can do a substitution. I did not actually show the substitution though, because as soon as I recognize that I can do the substitution, I don't actually have to write it out. If you want to and you're more comfortable with that, that's fine. My step would have been 2y squared plus 3y minus 5 equals 0. And then I would factor this. So it factors into 2x to the 1/3 plus 5 times x to the 1/3 minus 1 equals 0. Again, if you were doing the substitution instead of x to the 1/3, those would both be y's. But after that, you would have substituted back in the x to the 1/3. So now I solve, add 1, subtract 5, divide by 2. And now I have to recognize, okay, what is an exponent of 1/3? Remember that the exponent of 1/3 is actually the cube root. So to get rid of that, I raise both sides to the 3rd power. Since it's an odd power, I do not have to worry about extraneous solutions. So I end up with negative 125 over 8 and 1. Next one. We did some problems like this yesterday as well, so I want you to try this one on your own. Don't forget here you will have to check for extraneous solutions. Pause the video, try this, unpause when you're ready to check your work. Alright, so here we should end up with x equals negative 5 and x equals positive 2. How do we get that? Good question. Well, isolate the square root term. So I subtracted 4 to both sides. Now I squared both sides. It doesn't matter about the negative because when you square a negative it's going to become positive. So I square negative root 26 minus 11x, and that becomes 26 minus 11x. Square x minus 4, and that becomes x squared minus 8x plus 16. Bring everything over to one side, so I get x squared plus 3x minus 10 equals 0. This factors into x plus 5 times x minus 2, set each factor equal to 0, and solve for x. I do have to check for extraneous solutions. So go back to the original equation. If I plug in a negative 5, negative 11 times negative 5 is positive 55. 55 plus 26 is 81. The square root of 81 is 9. 9 times negative 1 is negative 9. Negative 9 plus 4 is negative 5. So that works. And the other answer of 2. 11 times 2 is 22. 26 minus 22 is 4. The square root of 4 is 2. So negative 1 times 2 is negative 2. Negative 2 plus 4 is 2. So that one also works. Next, x plus 3 to the 2/3 equals 8. Go ahead and do this on your own. Again, we did an example like this yesterday. Pause the video, unpause when you are ready to check your work. Alright, so here we end up with x equals negative 3 plus or minus 16 root 2. So we get two answers here. We do not need to check for extraneous solutions. I'll explain why if we don't remember. So first we have x plus 3 to the 2/3 equals 8. So again, recall from yesterday and other practice problems we've done, x plus 3 to the 2/3 is actually the cube root of x plus 3 quantity squared. So what do I do to get rid of that? I'm going to take the square root to get rid of the square, and I'm going to cube both sides to get rid of the cube root. The square root of 8 is 2 root 2. Don't forget plus or minus because I'm taking the square root. But then I'm cubing that, so that's how I end up with 16 root 2. Because when I cube this, I end up with 8 root 8, because 2 cubed is 8. The square root of 8, though, is 2 root 2, so that's how we get 16 root 2. Okay. So I get x plus 3 equals plus or minus 16 root 2, subtract the 3. Because we cubed both sides, we do not have to worry about extraneous solutions. Next one. Solve this. I will give you a hint. Factor out the greatest common factor. Pause the video, try that. Unpause when you're ready to check your work, or if you get stuck. Okay, so here we should get x equals 1 and x equals 2/5. How do we get that? So this one's a little tricky. So remember, my hint was take out the greatest common factor. What is the greatest common factor? The greatest common factor in this case is x minus 1 to the 1/2. Here I have x minus 1 to the 1/2. Here I have x minus 1 to the 3/2. So x minus 1 to the 1/2 is a factor of that. So if I take out x minus 1 to the 1/2, this term right here is left with just 3x. This term becomes 2, because of the 2, and then the x minus 1 to the 3/2 becomes x minus 1 to the 2/2. 1/2 plus 2/2 gives me 3/2. 2/2 is actually just 1 though. So this whole term is actually just x minus 1. So I can distribute this 2 and I get 2x minus 2. Combine like terms. I get x minus 1 to the 1/2 times 5x minus 2. Set each factor equal to 0. Square both sides here. So I get x minus 1 equals 0, so x equals 1. And I know x equals 2/5. Now I do have to check for extraneous solutions. I squared both sides. If I plug in 1, this works. Because 1 minus 1 is 0, 1 minus 1 is 0, 0 plus 0 is 0. That works. If I plug in 2/5, notice that 2/5 minus 1 is going to be a negative number. Also keep in mind that a 1/2 exponent is actually a square root. So remember, x minus 1 to the 1/2 is actually the square root of x minus 1. So I'm going to end up taking the square root of a negative. You're going to get imaginary values, but it does work to equal 0. But we do have to check. Okay, next one. A little easier. Rational equation. Pause the video, solve this, unpause when you're ready to check your work. Alright, so here we should get x equals -3 and x equals +1. How do we get that? Find my least common denominator. The least common denominator is x plus 1 times x plus 2. So I multiply each term individually by x plus 1 times x plus 2. When I multiply the first term by x plus 1 times x plus 2, the x plus 1's cancel and I'm left with 4 times x plus 2. The second term, the x plus 2's go away and I'm left with -3 times x plus 1. And then on the other side of the equation, I just multiplied this out, and I get x squared plus 3x plus 2. Distribute, combine like terms, and I get x squared plus 2x minus 3 equals 0. This factors into x plus 3 times x minus 1. Set each factor equal to 0, and I get x equals -3 and x equals +1. I do have to check for extraneous solutions, but if I plug either of those back in, I do not get a 0 in the denominator, therefore those are good solutions. Next one, absolute value equation. We did a lot of these yesterday. I want you to try this on your own. Pause the video, unpause when you're ready to check your work. Alright, so here we should end up with x equals -6, x equals +3. On the other version we also get x equals -6 and x equals -3. We do need to check for extraneous solutions, so when I plug those back in into the original with the absolute value, I see that both of them, or that all three of them work, so all of them are good answers. Now again, the process with absolute value. Do a positive case, so drop the absolute value and rewrite the equation. Do a negative case, so drop the absolute value, multiply one of the sides by a -1, so this became -3x minus 18, and now solve the equation. Both of these are quadratics. They both factor nicely. Set each factor equal to 0, and get your solutions. Okay, the last few examples are going to be on part 2.